Guys, in a previous video, I've described to you the importance of use of a total trap-out chimney tray to direct not some, but all of the liquid from the bottom fractionation stage into the reboiler. Again, the reason this is important is that the reboiler functions as the bottom theoretical fractionation stage of your tower. Again, you can see this on your computer output, which always assumes the bottom theoretical stage is the reboiler. And again, to assure this actually happens the way you're simulating it on your computer, I have this total trap-out chimney tray, which forces not some, but all of the liquid to flow through the reboiler, provided valve A, the startup line, is closed, which it is. But how about the very common distillation towers that have vertical baffles in the bottom of the tower? This is an extremely common design. It's done this way all over the world. Take a look at your towers that use a vertical baffle in the bottom of the tower. The liquid, of course, comes off of the bottom tray and falls into the cold side, the cold half of the bottom of the tower, which again is segregated into the cold side and the hot side by the vertical baffle. Fine, the liquid now flows as it should into the reboiler, and it now returns as per the industry standard, but not my standard, back onto the cold side of the reboiler, where it commingles with the liquid overflowing from the bottom fractionation stage. I think you could see that I have back mixed the effluent from the bottom theoretical stage of the tower, the reboiler, with the liquid draining off the bottom fractionation stage in the tower itself. And this combined liquid then overflows the top edge of the vertical baffle onto the product or hot side and is drawn off. Obviously, certainly, this causes a relatively large portion of the liquid from the bottom fractionation tray to bypass the reboiler completely. It's kind of the same as opening up valve A, my startup valve, on the chimney tray design. It's greatly diminishing the fractionation efficiency of the tower by bypassing the bottom theoretical stage of the tower associated with the reboiler. This is the industry way to do it, and this way is wrong. What's the right way to do it? The right way is to take the reboiler return and return it totally and completely, not to the cold side from whence it came, but to return it entirely onto the hot side, onto the product side. Now all the liquid feeding the once through thermosiphon reboiler comes from the bottom fractionation stage of the tower, as it should. And now the entire liquid portion of the reboiler effluent overflows, as it should, onto the hot side of the overflow baffle, thus greatly improving the efficiency. Guys, everything I say about these things are not drawn from a computer study, which you could do. It's drawn from personal experience. And as I talk to you, I have in mind exactly an experiment that we performed at a plant in Port Arthur, Texas, where I caused the liquid from the reboiler return to be directed exclusively onto the hot side of the vertical baffle. Now, of course, a lot of you people may have cut a hole in the bottom of this vertical baffle. Sometimes that's done for hydraulic reasons. But I hope you could then see that this kind of has the same detrimental effect as causing the liquid from the reboiler return be put back onto the cold side of the reboiler. So do the job correctly, do the job so that The vertical reboiler causes, the vertical baffle causes the reboiler to function like the bottom theoretical stage of the tower by taking not some, but all of the liquid from the reboiler effluent back onto the hot side. You may need a new nozzle for this. And both in theory and practice, and you can see it on your computer simulation, this will substantially improve the fractionation efficiency of your distillation towers. Just because people are doing something the wrong way for 100 years does not make it right. This is the industry standard way to do it, and this is my way. This is the wrong way, and this is the right way.